Welcome back, everyone, to today's Explainer. We're wrapping up a totally critical part of our software engineering syllabus today. If you've been with us, you know we've been deep diving into service-oriented architecture, or SOA. Well, today, we're going to master modern distributed architectures by tackling Section 18.4, Service Composition. I am super enthusiastic about this one, because this is literally where all those separate pieces we've learned about finally snap together to build some massive, powerful systems. Here is our agenda for today. We'll start with an intro to service composition, move into workflows and BPMN, talk about failures and compensation, walk through the 6 stages of composition, discuss the testing nightmare, and finally, do a rapid-fire Chapter 18 master recap. All right, let's jump right into Section 1, Introduction to Service Composition, Building the Grand Solution. So, up until now, we've mostly talked about building single independent services, but the real power, it comes when we link them all together into massive integrated applications, and we call this service composition. Let's look at the formal definition. It's the process of composing and configuring separate, reusable services to create new composite services or integrated applications. Basically, before we dive deeper, just understand that this means we are taking existing independent building blocks, which might even come from completely different companies, and wiring them together so they act as one unified software program. It takes separate business processes and integrates them into one powerhouse system. To make this super concrete, let's walk through the textbook's travel aggregator example. Imagine an airline wants to offer you a complete vacation package. They definitely don't want to build a whole hotel management system from scratch, right? Or buy a fleet of taxis. Instead, they use service composition. Step 1, their system uses its own internal service to book your flight. Step 2, it connects to a completely external hotel booking agency's service. Step 3, it contacts a local rental car or taxi service. And Step 4, it connects to local reservation services to book your attractions. It literally combines all these separate external services into one seamless vacation package for the user. It's like a giant puzzle coming together perfectly. Moving on to Section 2, Workflows and BPMN, Blueprinting the Process. Now, obviously, we can't just start writing code blindly. We absolutely have to design these business processes first. And that brings us to a highly important definition. A workflow is a sequenced model of a business process, consisting of a set of activities ordered in time where each activity carries out part of the work. Try to isolate this concept in your mind. A workflow is the absolute essential blueprint for service composition. It maps out the exact stages involved in reaching a goal and shows exactly what information is passed between those stages. This visual beautifully illustrates the concept. Take a look at how this vacation package workflow represents a linear path. It's passing information from one step right to the next. For example, you can see the arrival dates and times from the book flight service are passed directly over to the book hotel and arrange car or taxi services. To actually draw these workflows professionally in the real world, we use a specific notation. BPMN, or Business Process Modeling Notation, is a standard graphical notation used to draw business processes and workflows. Software engineers use this visual language to map out the exact behavior of the system. This way, literally everyone, from the hardcore developers to the business analysts, completely understand the process. Here is a fragment of an actual hotel booking workflow written in BPMN. Notice the specific symbols here. The rectangles with the rounded corners? Those represent activities, tasks that actually need to get done. The circles represent discrete events, like a start or an endpoint, and those diamonds represent gateways. Gateways are decision points where choices are made, like, say, whether rooms are available or not. Oh, and the dashed arrows show messages flowing back and forth between the hotel service and the customer. Now, I want you to notice the contrast between visual BPMN models and WSBPL. Obviously, computers don't run pictures, right? BPMN is just the visual workflow. But if you're using SOAP-based services, these visual workflows can actually be automatically translated into executable XML-based code, which is called WSBPL. So your visual diagram literally generates the executable program. How cool is that? All right, Section 3, Failures and Compensation Actions, the reality of the real world. Let's shift gears and talk about the inevitable complications of software engineering, because let's face it, the real world is messy. So let me pose this direct question to you. What happens in our travel aggregator if you successfully book a non-refundable flight in Step 1, but then the external hotel service reports no rooms available in Step 2 because there's a massive convention in town? This no availability report is actually super common. It's not a software crash, it's just a business reality. But you can't exactly leave the customer with a flight and nowhere to sleep, and you certainly can't let the entire program crash. So the absolutely crucial point here is how we handle it. And we do that using a compensation action. This is defined as an action used to undo a previously completed workflow step when a later activity fails or reports an incompatibility. Please explicitly anchor this in your notes as a crucial exam concept. In our scenario, you must trigger a compensation action to go back and mathematically undo or cancel that flight booking to minimize issues for the customer. You're basically resetting the state before asking them for new dates. Moving on to Section 4, the 6 stages of composition, step-by-step engineering. We're now going to cover the exact practical engineering methodology required to construct a composite service. This graphic outlines the whole process. I want you to really visualize the flow here. It takes us all the way from a highly abstract outline of a workflow through discovering and selecting external services, all the way down to deploying a tested, executable program. Let's briefly walk through each stage chronologically. Stage 1 is formulating an outline workflow, basically creating an ideal, abstract design based on your requirements. Stage 2 is discovering services, searching through catalogs for existing services that might do the job. Stage 3 is selecting possible services based on things like functionality, cost, and quality. Stage 4 is refining the workflow. That means updating your abstract design based on the actual services you found. Stage 5 is creating the executable program, literally turning that design into code or WSBPL. And finally, Stage 6 is testing the completed composite service. That brings us to Section 5, the testing nightmare, validating external code. Now, I need to warn you that final stage of composition, testing, is incredibly difficult. Definitely flag this as highly testable for your final exam. Why exactly is testing external service compositions harder than testing internal software? Well, first, it's black box testing. You don't own the external code, so you can't see the bugs hiding inside the hotel's server. Second, dynamic binding means the service might change its behavior completely unpredictably between runs. Third, pay-per-use financial risks. Think about it. If a third-party taxi API charges you a few cents for every call, running an automated test suite 10,000 times could literally bankrupt your project. And lastly, it is terribly difficult to test complex compensation actions because it requires simulating the failure of external services that you don't even control. Finally, Section 6, Chapter 18, Master Recap, Final Assessment Prep. Let's initiate a rapid-fire review of the key points from the entire chapter to make sure you're prepped for your final assessments. First, remember the core technical differences in implementation. We have the heavyweight WS star standards, which use SOAP for messaging and WSDL to define interfaces. And we contrast that with the lightweight RESTful APIs, which simply use standard HTTP verbs like GET and POST. Next, recall URL's service classifications. You need to ensure you can recognize the difference between utility services, like a currency converter, business services, like checking a credit rating, and coordination services, which are the ones that control workflows. Also, let's recap the 3 overarching stages of the service engineering process. You really need a perfectly structured mental model of this lifecycle. First, you identify candidate services to build. Second, you design their interfaces. And third, you implement and deploy them. Okay. Here is your ultimate summary for the chapter. The absolute core tenet of SOA is building systems out of independent, reusable, loosely coupled services. And explicitly, for your exam, make sure you can define exactly what a compensation action is. Also, ensure you can list at least 2 reasons why testing external service compositions is an absolute nightmare compared to testing internal components. I want to wrap up Chapter 18 by congratulating all of you on mastering modern distributed architectures. You now truly understand how the software that runs the world actually communicates. But I want to leave you with a provocative thought as we look to the future of software engineering. As service compositions and discovery become more and more automated, will human engineers eventually just manage the complex compensation actions while AI automatically writes and binds the basic workflows? It's definitely something to think about as you prep for the exam. Keep studying hard, and I will see you in the next explainer.